What's up, guys? It's Alec, and I'm back for episode 4 of the Code Drop series. Super excited there. Today we're going to be talking about how to Dockerize your Go service or whatever you're doing. So what we're going to be doing is taking that app we wrote for the third episode. I think it was a team app, and we're actually going to create a Docker file, which will allow us to spin up an image and a container. And we will create a Docker Compose file, which will allow us to do things like start up Mongo, start up your service, start up service discoveries like Console and Zookeeper, all in one command. It will just bring up a bunch of virtual machines, which is really cool. Really super lightweight virtual machines. If you don't know what Docker is, you should probably read up about it. It's really awesome, and it's actually helped my company do a lot of, or the company I work at, speed up the development tremendously. It's wonderful. So without further ado, stop my blabbing. We'll jump right in. All right, so I just got my terminal up right here. I'm just gonna flip over. I just opened the project we did last time in my text editor. So yeah, it looks like what we did was just create a team application. So I believe what that does is it uses Mongo in a local instance on your machine, which we don't really want to do. So what we can do is, while we are creating that Docker Compose file, we can wire up Mongo to our service without having to install it on our local machine, which is really cool. Because it will just pull a Docker image down, spin up a container, link it to your service that's been Dockerized, and you're good to go. So first things first, we need to create a new file. This is just a Docker file. I mean, it's like no extension, nothing. It's just Docker file with a capital D. It's really awesome. And so what we have to do is tell Docker what base image we're going to use. And what that's going to do is it's going to, in the Docker Hub repository, or wherever Docker keeps all their images, there's a bunch of these just basic virtual machines like CentOS and Alpine and NixOS and things like that. That what you can do is you can, on top of those, install what you need to install, like your service, for example. So we're going to tell our Docker file to run from the Golang 1.8 alpha, or I'm sorry, Alpine image. And that's just a really lightweight Linux container that has Go on it, basically. The Go path, I believe, in this image is at Go, /Go. So keep that in mind for later. And then we're going to, on startup of this container or image or whatever, we're going to tell it to update everything that's on the system right now. We're going to tell it to upgrade, and then what we're going to do is we're going to tell it to add no cache bash git and open SSH. That will allow us to do things like run go get and do dependency fetching, which is really nice, so we don't have to have local dependencies on our machine. Docker can take care of that for you. My personal recommendation is to have every developer fetch dependencies when they clone your repo. So I don't really like vendoring dependencies within a Docker container, but for convenience sake, we'll do that. And then what we're going to do is run this copy command. And what that's going to do, this dot says to take the current directory that you're in, mount it into the Docker container. And then you just give it a path to mount it to. So we're going to do Alec Holmes, and then code drop. And then team. So then what we're going to do is we're going to go get something called Cardianos Go vendor, and that will be the tool that allows us to handle all our dependencies. And then we're going to go into go source github.com Alec Holmes /codedrop/team, that directory that we were previously in. And we are going to run go vendor sync. That will basically, that's telling go vendor, this binary we fetched earlier, to do its magic and read the vendor JSON file, which is just a big JSON file that holds all the dependencies you need. It's like it holds like the git SHA, like GitHub URLs, other stuff, and it will just clone it all into a vendor repository, so you have all your dependencies right there. Then we're going to run go install github.com/ why am I blanking here? Oh yeah, it's Alec Holmes codedrop team, and that will install, it will compile your code that you wrote and access and put it in your Go path, which if you set up your Go path, if they set up their Go path correctly, the /bin folder, which is where this binary will be installed, will be in your system path, and you can just do like /team, which is really cool. So we're going to run add user team user. Just for security purposes, we're going to add a user, and we're going to tell the image to use that user. And then we're going to run with the command go bin team. That should be good. I think we might need to expose 8080. I can't remember. That should be all we need to do. So in summary, what are we doing here? We're taking the code we have on our local machine, putting it into a virtual machine, compiling it, running it. That's basically all, or fetching dependencies, compiling, running. It's basically all that's happening. It's really simple. This command is right here is what will actually execute that binary, and which will start your microservice. So the next thing we're going to do is we're going to create something called a Docker compose.yaml file. And we're going to say, I want version 2. This is the file that will allow us to write this command and start a cluster of whatever you need to start. So for example, Mongo, your service, Zookeeper, console, whatever you need. There's like a zillion images out there. You could do Zipkin for metrics, whatever. So what we're going to do is we're going to do Mongo image, Mongo latest, and then we're going to set up our service, and we will do team image, or actually we'll just do build dot depends on and we're going to say it depends on Mongo, which will then allow us to use that Mongo that it's going to spin up in our service. So we can remove the local dependency there, which is a big plus. We don't need to pass any environment variables in because I don't believe we set any in the in our code. I guess the last thing to do is do ports 8080 to 8080, which will just basically allow that exposed port to map to your local machine. It's like running a local host basically. So I mean, what we've just done is we've just basically given an outline for what we want to start up with one command. So this will, if we do docker compose up, what will happen is it will spin up a Mongo image. It will spin up your team image link them, and you're good to go. You basically have a fully functioning production environment, which is awesome. So now, last step, like I said, we removed a local dependency. So we need to go and change our Mongo connection string. And the really cool thing about Docker containers and images is their host name, when you want to access them from other Docker containers, is usually just whatever you define it in the Docker Compose file. So in this case, Mongo, so our host name and port would be Mongo, and then whatever Mongo exposes. So like if we wanted to access our team service from something else, we could do team:8080, and that would be how we connect to that. So if all goes well here, we could do a Docker compose up -- build. Remember that tool Go Vendor I was talking to you about? Well, we never actually set up the vendor JSON file in our team app. So why don't we go ahead and do that? We'll do Go Vendor init, assuming you have Go Vendor installed on your local machine. If you don't, you can just run the same command that we run in our Docker file, go get -u Go Vendor. We'll do Go Vendor fetch plus external. And what this is going to do is it's going to go and look at our source code, say, okay, this is an external dependency, this is an external dependency, this is in the standard library, we don't need to fetch this, we need to fetch this. We'll do that. And what it's going to do is it's going to plop this vendor folder. What that's going to do is inside you'll see this vendor.json file. This is essentially all the dependencies that our app uses. So now we have that. We can do a Docker compose up -- build. We should see everything successfully, all the steps successfully be run. All right, you can say creating team Mongo, creating team, which is that service. If all goes well, our service should be up. We see Mongo started. We should probably add a logging statement to see that our service would start, but we don't actually do that. It's bad code. We hit 8080, page not found. So if we go back here, we can see that our service is up. It is reachable. I believe if we go to /teams, null. Awesome. So that means nothing's in the Mongo database because we haven't seeded it. So our service is connecting to the Docker Mongo. It's all running as a cluster. And the best part is it started with one command, and you can stop it with one command. You just do Control-C, Docker compose down, and you've basically created a production environment with 2 commands. It's awesome. So I hope you guys found this helpful. If you have any questions, drop them in the comment section below. I try my best to answer them as quickly as possible. I am pretty busy with work and school. Feel free to leave a like. Let me know what you guys think. Hope I'm doing a good job. Glad you guys enjoyed this. See you in the next video. Peace.